review our logarithm test. Who has a question for me? Yes.
Number 9.
Number 9 and which one? The green or the blue? Green. Number 9 on the green. So, all right. I've got a log 4, log 4, log 4, right? Some of you, I think, just divided by log 4. Everybody? Can you do that? No. Let me show you. If I were to divide everybody by log 4, like this, I were to do that. Can't do that, right? Okay. So, before I can use the property equality of logarithm, I have to get these two logs together. Okay? In order to get these two logs together, I use the properties. What properties could I use? I see an addition sign. I could multiply them. I also have coefficients out here. What property could I use for those coefficients? It bring it up to here, right? That one's called the power property. Remember that? Yeah. Let's do that one first. Log base 4n equals log base 4 3 squared plus log base 4 2 cubed. That was the power property. I'll post all this too for you guys. Yes.
Are you going to post the answers to study that as well?
Not yet.
Or you will?
But I will.
Okay.
And we're going to go, I'll probably post it Wednesday night, and then we'll go over it on Thursday together. So you can check your answers.
Most of it or all of it?
All of it.
Okay.
Okay? So log base 4n equals log base 4 9, and I can use the product property, and instead of this being addition, I can combine the two and make it multiplication. Okay? Now I've got all straight multiplication, right? So now I can use the equality property and say, if this is the same base as this, then I can just say n equals 72. And the green number 9 would be the other one, the other number 9 on the blue is n equals 32. Okay? I'm going to make this nice and neat because this is the one I'm going to post. So this was the power property, and this was the product property, and this is property of equality. Okay? Next. Evan, you've got to give other people a chance. Yes. Number 5, on which one? The blue one. What do you see about both of these? They both have 4s, right? So I want to make them have common bases. So positive fractions are negative exponents. So I'm going to change it to 4 to the m plus 7 is equal to 4 to the negative 1. Again, property of equality says I can set them equal to each other now. m equals -8, right? And then number 5 on the other one, on the green, is n equals -5. Questions? Anybody else? Okay, so we're going to do number 10 on the blue. Okay, so I see a subtraction sign here. What does subtraction mean in logarithms? Divide. So I can say log base 8, 5 minus 2a, divided by, thank you, log base 6, 5 minus 2a over 3a equals 1. Okay, I can't use property of equality because are there logs on each side? No, so what's the only other thing I can do? Can I do anything else with this log? Put it this way. Can I manipulate this in any other way at this point? What? I can't do anything else with it. So since I can't do anything else with it as a log, what should I change it to? What? ln is not a log. ln goes with e, right? Log base something equals exponent. So since I can't work with it in logarithmic form, I'm going to switch it to exponential form. Right? If you saw, sometimes when you guys see this big old mess, you get confused. What if you had something like this? Log 6x equals 2. What would you do with that? You would do what? 6 squared equals x. Well, this is the same thing. Say it again. Uh-huh. Not over 1. Yeah, that's what I'm trying to say. I'm trying to say, when you see something and you get confused, give yourself something that's really simple and then ask yourself the same question. You guys see this and know exactly I should switch it to exponential form, right? Let's do the same thing. So I'm going to take the base, which is 6, just like Jesus said, to the exponent, which is 1, equals 5 minus 2a over 3a. So we really have 18a equals 5 minus 2a, which is 20a equals 5. So a equals 1/4. And on the green, the answer is x equals 1. Okay, let's do number 8. So what can I do with this? What would you, okay, let's turn it into something more simple. What if I had this? Log base 5x is less than log base 5, 2. What would you do with that? You can't change. I think what you guys are doing is you're confusing the properties. You can't do anything with this. This is a quantity, right? This is a quantity, right? So I can't do anything with it. If I had this, I can do something with that. I can put those two together. But when it's like this, this just stays like this. So it's the same thing as saying this is just a number. It's just like this. log base 5 question mark is less than log base 5 question mark. What do I do with that? Yeah, we set them equal to each other, right? Okay. So, I'm going to say 8x is less than 3x plus 10. Then subtract 3x from both sides and I get 5x is less than 10. So x must be less than 2. You have to always check when you have inequalities, right? Why? Because it's more than one answer, right? It means all the numbers that are less than 2. So what's the one important number that you really have to think about? Okay, so can x be 0? If what I'm saying is x is less than 2, well then could x be 0? Let's check. If x was 0, wouldn't this be saying log base 5 of 0? Can 5 to what power equals 0? 5 to the 1 equals 0? 5 to the 0 equals 0? No, it doesn't. Equals 1. So I'm asking you again, can x be 0? No, it can't. There's your answer. Do you understand why, Evan? You have to check. And what's the number you want to check? You want to check 0, right? Okay, so the blue is x is greater than 7. Do you have to check that one?
Sure.
Not really, okay? Because x is going, you only really want to check is when x is less than something that makes it 0 or negative numbers, right? You don't know why? No, you don't understand? Okay, I'm saying here's a number line. Okay, here's 0, here's all my negative numbers. If I tell you my solutions are everything that's above 7, are there scary numbers up here? Here's the scary numbers right here. The 0, the negatives, right? Because those things can have an effect on it, right? Because every time you go from one number to make it to 0 or negative numbers, those things have an effect on something. Do you see why now if I were to say x is less than 2? I just lost power. Come on. Here's 2. If I say that x is less than 2, this is where we get into trouble. Because now we're going into 0 may have an effect on it, right? But when I go x is greater than 7, I'm getting away from the danger, right? So those are fine. Okay? All right, pausing. Okay, let's do number 6 on the green. Okay. Do you see anything that these have in common other than the x? 2. I can change 32 into a 2 by saying what? 2 to the what? 5th. X is less than 2 to the 4th. X plus 2. Now that they have common bases, I can compare their exponents. So 5x is less than 4x plus 8. So x is less than 8. What do we need to check? 0. Does it make sense if x was 0? 32 to the 0 makes what? 1. 0 plus 2, 16 squared is 256. Is 1 less than 256? Does 0 work?
Yeah.
So do we have any problems? Nope. See what I mean? And the blue answer is, x is less than 2. Oh, because we just did that one? No, that can't be right. Yes, x is less than 2. Put that one in blue. Okay, let's do number 13 on the blue. Couple different strategies we could use, right? I could put ln on both sides. Then what? This cancels out because this is, ln has an imaginary e right there, right? So that cancels out. And we're left with negative 3x is less than or equal to ln 18. Then you just have to divide both sides by negative 3. And you get x is less than or equal to, let's see what I have here. Negative 0.9635. Only what do I need to change? The sign. Why? Because I divided by negative 3, right? So I need to change the sign. And the green? Number 13 is x is greater than or equal to negative 0.5493. All right, let's do number 15 on the blue. So it says, in 5 years, radioactivity reduces the mass of a 100-gram sample of an element to 75 grams. So a 100-gram sample goes down to 75, right, after a certain amount of time. Find the constant K for this element using y equals a e to the negative kt, round to 4 decimal places. So I have everything here. The only thing I need is what? Only thing I need is K. So let's substitute. What would Y be? Well, here. We have T. T is what? 5 years. Okay, so it says in 5 years something reduces. So if I start with one thing and I apply something to it and I get something else, which one is going to be Y? Is it going to be 100 or is it going to be 75? What? Why 75? No. 75 is not my original amount. This is the original amount right here. Right? You always start with A in the alphabet. So we're starting with A and our sample. You have A, you apply e to the negative kt to it, and you get Y. If it was reduced, which one would be my original amount? 75 grams or 100 grams? 100. So my A, my initial amount is 100. Right? The amount lessens. This also tells you right here if it's negative sign. So then what's Y? 75. Do I have everything I need? Yes. So I have 75 equals 100 e to the negative k times 5. So how would I solve that? Divide by 100, which is 3/4, equals e to the negative k 5. Ln of both sides. We'll just switch that around. 5k. This cancels, and I'm left with ln of 3/4 equals negative 5k. Divide by negative 5. Divide by negative 5, and you should get k is about 0.0575. On the green, k is about 0.0578. Does it seem easier now? You guys are just full of talking. Huh. Okay. All right, so let's do number 16 on the blue. Okay, you know what I think is the hardest thing on this problem is changing 5.8% into a decimal. Okay, a savings account deposit of $3,000 is to earn. Earn means it's going to be increasing, right? So what's A going to be? Is A going to be the 300 or the 900? The 300. I already know what's going to happen after I apply the 5.8% interest for so many years. How much am I going to get? 900. And did they give me my rate? They sure did. It's 5.8%. I saw this on these tests. I remember. Some people had a hard time with this. If you forget, look at 100%. Remember, I always tell you, if you forget something, take it back to something that's easy. How much is 100%? 1. Right? How'd you get from this to this? 2 decimal places. So how am I going to get from 5.8% to a number? Move over 2 decimal places. Make sense if you forget? Okay. And don't feel bad. This is 7th grade standard. No, I'm not trying to. No, I'm not trying to make you feel bad. But how often do you use it? You don't really use it, right? No. That came out wrong. We'll erase that. We don't need to put that. Okay. I was recording, yes, I know. Okay, so if I set this up, I would say 900 equals 300 times 1 plus 0.058 to the c. Now what do? Divide by 300. These cancel. I get 3 equals 1.058 to the c. Now what do? Take a log of both sides. Couldn't I just turn it into logarithmic form? And the same thing? Yeah? So what's my base? 1.058. What's my exponent? 3 is my exponent? You get the same place, right? What's my exponent? Think of this. Put this on your paper when you do this. Log, space, box, equals exponent. Right? Right? Yes, Mrs. Muller, we know, yes, absolutely. So what goes here? That 3 is the exponent? T is the exponent. Right? It says right there exponent. Where's the exponent? Is 3 the exponent? No. Right? You see what I mean? What goes here? 3, the only thing that's left. All right. So I would do the change of base formula for this now. Correct? The base goes in the bottom. Base goes in the bottom. So I would have log of 1.058 and log 3. Put that in a calculator and you get what? Which one is this? $19.5. And it said round to the nearest tenth. So that's the blue. On the green, T is about 17.4. All right, let's do 12 on the blue. Can you do anything else with this in the form that it's in right now? You can't manipulate it in any other way, right? So what should I do with it? If I can't do something with it in this form, what should I do? Put it into another form. What form would that be? Exponential form, right? Okay, what's the base of this already? E. So E to the what? 4 equals x plus 4. Subtract 4 from both sides, and you get x. Testing. Is anybody there, guys? X. All right. Number 12. You put that in the calculator, and you get x is about 50.598. Yeah, that's why there's a blue square right here. Green is x is about 25.0855. Do you guys realize there's another way to do this? You could put e to the this and e to the that. Right? Don't I get the same thing? X plus 4 equals e to the 4th. Don't you get the same thing when you do that? Okay. All right, let's do number 14. So it says use the change of base formula. So change of base formula is log of this over log of the base, right? So, tapping, please stop. Log 5 over log 15. You put that in a calculator and you get 0.5943, and on the green you get 0.5579. Okay, let's do number 15. After 12 years, half of 16-gram sample. So T equals 12 It says 12 years right there, right? Half of a 16 sample, so what's A? What did it start with? No, A. What is A? What did we start with? 16. What did we end with? Half, which is 8. Right? So find the constant K. So we started with 16. We gave it e to the negative K times 12 years. And we got out 8. Correct? Okay. Okay. All right, so let's divide by 16. We'll get your stuff out. So I get 1/2 equals e to the negative K 12. Can I do anything else with this? I can? I can't do anything else with this. What am I going to do? Change it, right? So I'll put ln 1/2 equals ln e to the negative 12k. This cancels out. ln 1/2 equals negative 12k. Divide by negative 12. K is about, and we already did the other one. So 0.578.